Let's talk about something truly spectacular. Something that's all around us, and yet so simple it's almost unbelievable. I'm talking about hydrogen. Consider this. If you could count every single atom in the entire universe, a staggering 3 out of every 4 atoms you'd find would be hydrogen. That's right. It's the most common element in the cosmos, by a long shot. It's the original building block, the stuff from which everything else was made. From the farthest galaxies to the nebulae where new stars are born, hydrogen is the undisputed king. It's the alpha element, the #1 ingredient in the cosmic recipe book. So, what makes hydrogen so special, so fundamental? It all comes down to its beautifully simple structure. An atom of hydrogen is as basic as it gets. Imagine a tiny solar system with just one planet and one star. That's pretty much what a hydrogen atom is like. At its center, you have a nucleus containing just a single proton, which has a positive electrical charge. Whizzing around that proton is a single, solitary electron, which has a negative charge. That's it. No neutrons, no complicated shells of electrons, just one of each. This elegant simplicity is the reason it was the very first element to form after the Big Bang. Because hydrogen is everywhere, it plays a starring role, literally, in the universe's grandest spectacles. Look up at the night sky, and you'll see countless stars, including our very own sun. What do you think is powering those magnificent celestial furnaces? You guessed it, hydrogen. Stars are gigantic balls of gas, mostly hydrogen, held together by their own immense gravity. Deep within their cores, the pressure and temperature are so incredibly intense that hydrogen atoms are forced together. This process, called nuclear fusion, smashes hydrogen atoms together to form helium, releasing a truly mind-boggling amount of energy in the process. That energy is what makes stars shine, giving off the light and heat that travel across vast distances of space. Our sun has been burning hydrogen for about 4.6 billion years, and it has enough fuel to keep going for another 5 billion years or so. Every ray of sunshine that warms your face, every photon of light that allows plants to grow is a direct result of hydrogen atoms fusing together 93 million miles away. It's not an exaggeration to say that hydrogen fusion is the engine that drives life on Earth. Without it, our planet would just be a dark, frozen rock. So next time you feel the sun's warmth, give a little nod to hydrogen. Now let's get into some of the weird and wonderful chemistry of hydrogen. Because of its simple structure, just one proton and one electron, hydrogen doesn't quite fit in with any single family on the periodic table. It's like the ultimate chemical chameleon, able to change its behavior depending on its circumstances. Sometimes, it acts a lot like the elements in Group 1, the alkali metals. These include lithium, sodium. Like them, hydrogen has one electron in its outer shell. It's quite happy to give that electron away to form a positive ion, H+. This is the behavior we see when hydrogen forms acids. But hold on, hydrogen has a totally different side to its personality. It can also behave like the elements in Group 17, the halogens. Examples: fluorine, chlorine. The halogens are one electron short of a full shell, eager to grab an electron. Hydrogen's shell can hold 2 electrons, so it's also 1 electron shy. So in some situations, it will snatch an electron to form a negative ion, H-, a hydride. This dual identity makes hydrogen truly unique. That two-faced nature means hydrogen appears in an incredible variety of compounds. When it gives away its electron, it's a key component of water, H2O, hydrochloric acid, HCl, and almost all organic molecules. Examples in life: your DNA, the proteins in your body, the carbohydrates you eat for energy. Hydrogen is the glue holding together the molecules of life, essential to every living thing. It's not just out in the stars, it's inside every one of us. On the other hand, when it gains an electron to act like a halogen, it forms hydrides, like sodium hydride, NaH. That behavior is less common but important in industry and chemistry. The ability to donate or accept an electron makes hydrogen incredibly versatile. It can bond with almost any other element, from metals to nonmetals, creating a vast chemical landscape. It's this flexibility, this refusal to fit in a single box, that fascinates chemists. It's a true original. Let's shift gears and talk about energy, because hydrogen packs a serious punch. When you compare it gram for gram with other fuels, hydrogen is an absolute champion. It contains more energy by mass than any other common fuel we use. To put that in perspective, 1 kilogram of hydrogen has about 3 times the energy of 1 kilogram of gasoline or diesel fuel. That's an incredible amount of power locked inside such a light and simple element. This high energy density is why it's used as a rocket fuel, helping to propel spacecraft like the Space Shuttle into orbit with tremendous force. Now, here's the part that gets scientists and engineers really excited. When you burn a fossil fuel like gasoline, you release a lot of nasty stuff into the atmosphere. Carbon dioxide, soot, and other pollutants that are bad for our health. But when you use hydrogen as a fuel, something magical happens. Burn it in an engine, use it in a device called a fuel cell to generate electricity, the only byproduct is water. That's it. Just pure, clean H2O. No carbon emissions, no smog, no pollution. Imagine a world where our cars, buses, and even power plants run on hydrogen. The exhaust pipes would drip clean water instead of spewing out harmful fumes. This is the promise of the hydrogen economy, a future where we can power our society without damaging our planet. A fuel cell works by combining hydrogen with oxygen from the air in a chemical reaction that produces electricity and water. It's like a battery that never runs out, as long as you keep supplying it with hydrogen. This clean, efficient process could revolutionize the way we think about energy and transportation. Of course, there are still challenges to overcome. Producing hydrogen in a clean way, often using electricity from renewable sources to split water, storing it safely, and building the infrastructure to distribute it are all big engineering puzzles we're working on. But the potential is undeniable. Hydrogen offers a path toward a sustainable future, a way to meet our energy needs without compromising the health of our environment. It's a powerful reminder that sometimes the simplest solutions, like an element with just 1 proton and 1 electron, can be the most powerful of all. Consider the possibilities. Just when you think you have hydrogen figured out, you discover it has a family. Most elements come in different versions called isotopes. Isotopes are atoms of the same element that have the same number of protons, but a different number of neutrons. For hydrogen, there are 3 main family members. Protium, 1H. It has 1 proton and no neutrons, making up over 99.98% of all hydrogen in the universe. It's the lightweight, standard-issue model of hydrogen, the simplest atom possible. Deuterium, 2H, also known as heavy hydrogen. A deuterium atom has the standard 1 proton, but also 1 neutron, making it about twice as heavy as protium. While it's rarer than protium, it's not radioactive and is perfectly stable. You can find it naturally in water. About 1 in every 6,400 hydrogen atoms in seawater is deuterium. When deuterium combines with oxygen, it forms heavy water, D2O. Heavy water looks and tastes like regular water but is slightly denser. Those density and nuclear properties make it useful in nuclear reactors. Tritium, 3H. Tritium is the heavyweight, 1 proton and 2 neutrons, 3 times the mass of protium. Tritium is unstable and radioactive, decaying with a half-life of about 12.3 years. It's extremely rare in nature but can be produced in nuclear reactors. Because it glows in the dark, it excites phosphorescent materials. Tritium is used for self-powered lighting, emergency exit signs, watch dials, glowing gun sights. Finally, let's talk about hydrogen under extreme pressure. Hydrogen is the lightest gas, with very low boiling and melting points. Squeeze it with forces millions of times Earth's atmosphere, and something amazing is predicted. It transforms into a liquid metal. Metallic hydrogen would conduct electricity like copper or gold. Scientists think this exotic state may exist deep inside giant gas planets like Jupiter and Saturn, where gravity creates immense pressure. Back on Earth, researchers are trying to create and study this bizarre material, which could be a revolutionary superconductor. Hydrogen truly is an element of extremes.